These are some motors for small motion control systems. The ones on the left are DC motors. They're very simple. They have two electrical connections. You apply a DC voltage to it and the shaft turns. Reversing the voltage will reverse the direction of travel of the motor. To a certain extent, changing the voltage on the motor will change the speed, but in most cases it's desirable to use a pulse width modulation unit like this one. It allows a much larger range of speeds and allows the motor to have more torque when not running at full speed. There's a connection for power, and there's a connection for the motor, and a knob that you turn to make it go slower or faster. Another way, a more sophisticated way of controlling DC motors is Dynamic Perception's MX2 Dolly engine. It can do everything that this does, as well as some more sophisticated techniques such as shoot, move, shoot, where the motor moves a little bit and then pauses and waits for the camera to take the next shot. It can also ramp speed, gradually increasing speed into the move and ramping out, gradually decreasing speed towards the end of the move. DC motors like this don't have a lot of torque, and they run best at very high speeds. So most of the motors that you'd use for motion control will have a gearbox of one sort or another. This Dayton gear motor comes with gearboxes of varying gear reductions to allow the motor to go various speeds. It's the motor that was supplied with all the original Dynamic Perception Stage 0 dollies. This smaller gear motor from Servo City comes in lots and lots of different gear reductions from them, depending on the approximate speed you want to move your dolly. The motors over here are stepper motors, and they work in a completely different way. Most of them will have at least 4 wires coming out of them, and supplying a DC or AC voltage across a few of these wires will do nothing but ruin your motor. They're driven either by small circuits like this, or in the case of larger motors, a circuit like this. These are stepper motor drivers, and they want to see an input, a digital input that tells them which direction to move the motor, and another digital input that says when to make steps. In most cases, each step rotates the shaft of the motor 1/200th of a revolution. So to turn the shaft on the motor 1 revolution, you need to send 200 steps to the driver. The drivers are capable of accepting thousands of steps per second, so the motors can move at a pretty good speed. Again, these motors don't have a lot of torque, so in most cases you'll be using stepper motors with an attached gearbox. This motor from Fidgets has a 30-to-1 gear reduction through a planetary gearbox here, and is a great motor for running dollies or other medium-duty motion control applications. There are much smaller motors like this one, which we use as a focus motor. Of course, the drivers for these require step and direction signals. One way to control the drivers, which in turn control the motors, is to use something like our Dragon Frame breakout circuit, which plugs into the USB port on your computer and gives you step and direction signals at these TRS plugs. Another way to control stepper motors is using your dynamic perception MX2 Dolly engine as a user interface to tell it how far to move, which direction to move. It can even ramp in and out of shots. Of course, this isn't made to run stepper motors, but we have this interface which we call the Stepout protocol converter. It makes running a stepper motor just as easy as it could possibly be from the MX2 Dolly engine. You plug 12 volts in here. You plug a cable from the motor port on the MX2 to this plug, and it's ready to go. Adjusting speed, direction, shoot, move, shoot mode, ramping, any of the features on the MX2 will cause your stepper motor to behave in an appropriate way.